Good morning. Today, March 18, 2020, and our subject is electronic equipment maintenance and repair. By the way, this is Teacher Red. I am going to discuss to you how to read and how to trace a schematic diagram. So, by the way, this schematic diagram is a diagram of a power supply system, what we call switch mode power supply system. It is used in many electronic devices like LCD TV, DVD, laptop charger, mobile charger, and many other electronic device. So, we will start first, starting from the AC 220 volts input, which is here, up to the bridge diode. So, by the way, bridge diode is a circuit that converts AC into DC or direct current. So take note that this diode is directly connected to a 220 volts input. So let's start with line 1. So I will trace here from this line 1. Okay. Then the current will flow through a switch case 801 and then passes through a fuse which is FSH01 from the diagram, and then passes through a coil L501 also from the diagram, and then it is connected to bridge diode which is at the cathode of diode 501 and anode of diode 503. So take note that this is AC, no? AC input. AC input. Now, if you have problem or difficulty in tracing, how did I come with this point? So please always remember that the input to a bridge diode is always connected at one anode and one cathode, which in this case it is connected at the cathode of diode 505 and at the anode of diode 503. So you can also trace backward like this, no? So you look for these 2 points, one anode, one cathode, and then trace backward, so until you reach the line 1. So that is another technique, no? If you are new. And but if you are already familiar, then it's easy for you to trace. So always remember that the AC input is connected at one anode and one cathode of the bridge diode. So AC. Now, so let's try this. Okay, for example, I try it backwards. So I will look for the two terminals of the bridge diode, one anode, one cathode. So which is this one? Via diode 506 and diode 504. So here is the cathode and this is the anode. So I trace it backward. Okay, so this is the AC input, by the way, and then I follow the line. It passes through this resistor R502 which is 6 watt 3.9 ohms, and then until you follow the line, and then again you will pass through this coil L501 and through a switch, and then finally to line 2. So now we finish tracing the current flow from the main line to the AC input of the bridge diode. Now let's take at the output of the bridge diode. By the way, the bridge diode, again, it converts AC into DC or direct current. So for the bridge diode, the output is connected between these two terminals, which is both cathode of 503 and 504 in this case. So this is the positive current output, and the other side, which is connected to both anode of 505 and 506 of the bridge diode, this is the negative side. So this output now is of course DC. So this is DC output. Okay, so that output is connected to, of course, always remember it is connected to a capacitor, which in this case is 507 and 400 volts, 120 microfarad. So take note, this is very big voltage capacitor. So take note when measuring this capacitor. So, and then the output of this capacitor is fed or connected to a primary of the switch mode transformer, which is this one, switch mode power transformer. Okay, so this is connected to the primary, the output of this bridge diode here, and then also connected to a power regulator. So this is a switching regulator transistor which produce pulses, okay, applied to the transformer. Now, the negative side of the capacitor is connected to other terminal of switch mode power transformer, which is at terminal 3. So once this transistor makes switching, so this transformer produces a square wave pulse, which is of course AC. Square wave, no? This is no longer sine wave. So, and by the way, it has a very high frequency that is around 40 to 50,000 hertz. As you can see here, the output of the transformer, it has many outputs. You have terminal 11, 13, 14, and 16. So, this transformer now step down this high voltage into low voltage. Okay, so now let us try to trace now the secondary output of the transformer. So let's start with the number 11. So this is pin number 11. Okay, so this is connected to a diode, of course, that is to convert again AC into DC. By the way, this diode is not an ordinary diode. It is a Schottky diode. So this is a high switching diode. So this converts AC to DC. And then, as you can see, the output gives us 110 volts. Next, we have pin number 13. So again, it is connected to a diode. Take note, this is always connected to a diode because this is AC, so it has to be converted to DC. Okay, then follow this line, okay, until you reach this resistor, which is 412, 1 ohm, 1 watt, and then it has output of 27 volts. Next is number 14. Again, it is connected to a diode. Then, going up, it is connected to resistor 503, and then to a regulator transistor. It has output of 8 volts. Also, on that same line, there is a tap here. Again, it is connected to a resistor 572, 10 ohm, 1 watts. Another resistor, 10 ohm, 1 watts. And to a regulator transistor with an output of 5 volts. Next is number 16. So number 16, okay, so it is connected downward again to a diode. So the diode converts AC to DC, and it is connected to a resistor R562, which gives an output of positive 14 volts. By the way, another line here, going here. Okay, so this is also connected to a resistor and then to a regulator IC 7805, and this gives an output of 5 volts which is supplied to the CPU. So as you can see here, how I come up with tracing, you can also trace backward. For example, trace this 14 volts output going backward, so it is connected here, or that is another technique. If you have difficulty in tracing where this line will be connected, so you can, for example, trace from the output voltage and then trace backward. Okay, so and this output voltage now will be supplied to the different circuits of your motherboard. So this one is supplied, for example, to the flyback. This is for the vertical section. The other one is for CPU. This is for sound section and other circuits that needs DC supply. Okay, so I hope you understand and find time to analyze how to trace the schematic diagram. So next time we are going to do it in actual circuit in my next video. So thank you very much.